Here are the solutions to the VCAA 2017 Further Mathematics Written Examination 2. We are going to start with Section A Core Data Analysis. Question 1. The number of eggs counted in a sample of 12 clusters of moth eggs is recorded in the table below. Part A. From the information given, determine, Part I, the range. We know that the range is equal to the maximum value take away the minimum value. The maximum value is 197 and the minimum value is 125. So the range is 72. This question is worth 1 mark and this is going to be an answer mark. Part 2I. Determine the percentage of clusters in this sample that contain more than 170 eggs. We have 172, 192, and 197. So there are 3 out of 12 times 100 equals 25%. This question is worth 1 mark, and this is going to be again an answer mark. In a large population of moths, the number of eggs per cluster is approximately normally distributed, with a mean of 165 eggs and a standard deviation of 25 eggs. Part B. Using the rule 68, 95, 99.7%, determine, in Part I, the percentage of clusters expected to contain more than 140 eggs. Let's start by constructing a normal distribution with a mean of 165. One standard deviation to the left is represented by 140. So we need the percentage in the shaded area. We know that between one standard deviation to the left of the mean and one standard deviation to the right of the mean represents 68% of the data. Because the normal distribution is symmetrical, half of this region is going to be 34%. We also know that to the right of the mean, we have 50% of the data. So we have 34 plus 50, which is 84%. This question is worth 1 mark, and this is going to be again an answer mark. Part 2I. Determine the number of clusters expected to have less than 215 eggs in a sample of 1000 clusters. If we calculate 2 standard deviations to the right of the mean, we end up with 215. So this is the shaded area that we need the percentage for. We know that between 2 standard deviations to the left of the mean and 2 standard deviations to the right of the mean, we have 95% of the data. Outside to the left we have 2.5% and outside to the right we have also 2.5%. So the shaded region has 2.5 plus 95, which is 97.5% of the data. Recall that the question is asking for the number of clusters, which means that we need 97.5% of 1000, which is 975. This is a 1 mark question for the correct answer. From the 2017 VCAA examination report, many students overlooked the requirement to convert from percentage to quantity and gave an answer of 97.5%. Part C. The standardized number of eggs in one cluster is given by z equals negative 2.4. Determine the actual number of eggs in this cluster. Let's start from the formula z equals x minus x bar over sx. We substitute z equals negative 2.4, x bar, which is the mean, 165, and the standard deviation Sx equals 25 into the equation above. We can now multiply both sides of this equation by 25, and we end up with negative 60 equals x minus 165. We add 165 to both sides of the equation, and we end up with x equals 105. This question is worth 1 mark, which is going to be an answer mark. Question 2. The back-to-back stem plot below displays the wingspan in millimeters of 32 moths and their place of capture, forest or grassland. Part A. Which variable, wingspan or place of capture, is a categorical variable? Wingspan is definitely a numerical variable, while place of capture has two categories, forest or grassland. So the categorical variable here is place of capture. This question is worth 1 mark for the correct answer. Part B. Write down the model wingspan in millimeters of the moths captured in the forest. For this, we are going to look at the left-hand side of the back-to-back stem plot. The score that occurs most often is 20. So the model wingspan of the moths captured in the forest is 20 millimeters. This question is also 1 mark for the correct answer. Part C. Use the information in the back-to-back stem plot to complete the table below. First, we need the minimum wingspan for the moths captured in the forest. So again, we look at the left-hand side of the back-to-back stem plot, which is 16. To determine the third quartile for the wingspan of the moths caught in the grassland, we look at the right-hand side of the back-to-back stem plot. There are 19 scores, which means that the median is the 10th score, which is 30. The third quartile is the median of the top half of the data. There are 9 scores above the median, so Q3 is the 5th score out of this half of the set of data, which is 36. This question is worth 2 marks, 1 mark for each correct answer. Part D. Show that the moth captured in the forest that had a wingspan of 52 millimeters is an outlier. For this, we need to calculate the upper fence using the formula Q3 plus 1.5 times IQR. On the left-hand side of the back-to-back stem plot, there are 13 scores, which means that the median of this set of data is the 7th score, which is 21. There are 6 scores on either side of the median, so to calculate the first quartile, we have to calculate the mean of the third and the 4th scores. That gives us Q1 equals 20. We do the same thing for Q3. Q3 is between the 3rd and the 4th scores on the other side of the median. So Q3 equals 32. The interquartile range, IQR, equals Q3 minus Q1, which is 32 minus 20, that is 12. Now we substitute the values we have into the formula for the upper fence. 32 plus 1.5 times 12, which is 32 plus 18, that is 50. The score 52 is greater than the upper fence, 50. This means that 52 is an outlier. From the 2017 VCAA examination report, a concluding statement that clearly showed that the student understood why 52 was an outlier, given that the upper fence was 50, was required. So this question is worth 2 marks. So 1 mark would be for the upper fence, and the 2nd mark would be for the concluding statement. Part E. The back-to-back stem plot suggests that wingspan is associated with place of capture. Explain why, quoting the values of an appropriate statistic. The appropriate statistic here is the median. So the median of the wingspan of the forest moth is 21. The median of the wingspan of the grassland moths is 30. Since the medians differ in the two places, this suggests the association between the two variables. From the 2017 VCAA examination report, full marks were awarded to students who described the change in the median values and quoted these medians for both places of capture. The mean is not part of a stem plot 5-number summary and was not appropriate to use because of the outlier of 52 in the forest data. Students who initially gave the required median comparisons and then went further by quoting comparisons of other irrelevant statistics were not awarded full marks.